the key words that we're going to cover. So chromatography, which we just talked about. For those of you that teach chemistry, those of you that teach biology, honors biology, AP biology, you talk about properties of water, you talk about the cell membrane. So that kind of gets into this like polar and hydrophilic and nonpolar and hydrophobic terminology. Chemistry, if you talk about like the hydrocarbons and any kind of like intermolecular forces, that stuff plays a part with this lab. Are we okay so far? Okay. So, in order to prepare for the lab, we have to talk about an equation. In class, we just say C1V1. Like that's how we say it. And now that I've gone over it a ton in my class, my kids know how are you going to solve that C1V1? But C1V1 equals C2V2. How many of you have used that in your classes right now? Does anybody use it for anything? Okay.
Remind me what it stands for. I might write it differently.
So this equation is used to take like a stock solution or something that's stronger, like a more strong concentration, and dilute it. So C1, it's my little sticky note. Your C1 is going to be the initial concentration of the substance or solution that you have. V1 is going to be the volume of that solution that you need. C2 is going to be the desired end concentration, and V2 is going to be the desired end volume. So,
I write it M1V1, M2V2. I write it
okay,
M for molarity. But
right.
same
It,
thing.
it is. It's the same thing, and we use that when we do like titrations and stuff, right? So, this is like, so next week, for example, or not next week, but in 2 weeks, any kind of solution that you have, like you're going to have what we say is a 50x TAE solution, and you're going to need to dilute that down to a 1x. It's saying that something's like 50% or not 50% more concentrated, but it's way more 50x is way more concentrated than 1x, so you have to dilute it. Okay, in this lab, you guys should have 70% alcohol, right? And we are going to make a dilution where we take some of that 70% alcohol, so some of that V1, with our initial concentration of 70%, and we need to add water to it to dilute it for a specific volume. Does that kind of make sense? Okay. So in the in sorry, my ankle itches. So if you guys look at the lab, which is it says, let's see, can you guys see that? It says Kool-Aid chromatography, and it has the materials that you need. It's in your binders. Does everybody find this sheet?
Yes.
Okay. So if you look down, it gives you the purpose. So we're going to be doing chromatography. We're going to separate molecules based on their polarity. And then it gives you the materials. And then safety procedures. You'll want your kids to wear goggles, maybe gloves, especially if they have cuts because they're working with 70% alcohol. So, that's going to sting. And then if any of you have any kind of flammable equipment or gas or anything, obviously you wouldn't want any of the alcohol at the tables with if other kids have a Bunsen burner lit. Um, and then the next part is preparation. So this is what we're gonna work out together. So if you look, it says we are going to prepare 500 milliliters of a 25% isopropyl alcohol solution using distilled or deionized water. Okay. So if you go back to our equation and then you look at number one, what are the variables that we can fill in? You guys can tell me.
C2.
Okay, so what is C2?
5%.
Well, for number two, it would be 5%. We're gonna do both. For
So
one,
Oh, I'm sorry. I forgot what.
no, that's okay, that's okay. So C2 is 25%. Anything else we can fill in on our equation? Do we have the desired end volume?
We have our V2 as well,
Yes, so what is our V2?
500 millis.
500 milliliters.
Sorry, I'm used to calling it millis to my kids. Sorry.
No, that's cute.
I like Millie's.
Yeah. What is can we do anything with the C1 or the V1?
yes, your V1. I'm sorry, your concentration one, right?
Yes.
That's 0.7.
Actually you just use 70.
Okay.
Yeah. And then we're going to be solving for V1. So your equation should look set up like this. Is everybody okay with that?
Can you put back the sticky note one more time? The previous one?
Yes.
I just didn't get. Got it.
I can put this here. And sometimes, depending on your classes, when you bring this equation up to them, if you ask them if you have like 100% of something and you want to make 50%, usually they can tell you you just need to take half of that and add water. You know what I mean? But this it's not as easy as just 50 diluting it by half, 25%, 5%. So and so if they have a hard time, you could also do this maybe with like different amounts of like an colored solution, and then each time you dilute it, you can see that you're adding water and the color is getting lighter and lighter and lighter. So they could see a 25% solution is more like red than a 5% solution. Just if they need a visual to help.
Can you explain why the percentages are left as whole numbers and not converted into decimals?
That's a good question. I don't know right now. Can I get back to you?
Yeah.
Do you know
Seven
right off the
said-
top, Megan?
Yeah, you can do it either way.
Yes.
It would
Yeah.
be the same because it's a ratio, correct?
Right.
Yeah. Okay.
Okay, perfect. My mathing is
Either way, it should yield you the same answer.
It
the
does.
Same amount of volume, yeah.
all right.
Yeah.
So are we good with the setup? And then to solve this, you would multiply 25 by 500 and then divide by 70. Perfect. So Haley, can you tell us what our V1 should be?
Yes, ma'am. I got, and I don't know if we're taking into account into sig figs, but 178.6 milliliters. We do sig figs. We might have to round that up to 180.
Oh, yeah, this is perfect. Or, it also depends on your equipment that you're using, so once you have your V1, we wanted to make 500 total milliliters, right? So basically we need to add water up to so that it equals 500 total milliliters. Okay? And that would give us our 25% alcohol solution diluted from 70. Yes.
I'm sorry, can you go back to why do we have to add that again to get to 500? What, say that again? Can you
So
explain?
that, yeah, I'm glad you asked. So the V1, this is the amount of alcohol. This is the amount of 70% alcohol that you need to take to add to water. And adding that amount of 70% with what, 300 and 22 milliliters of water is enough to dilute the 70% with the water down so that the alcohol percent is now 5. Are you okay with that?
Yes, thank you.
Okay. Questions? Okay. Do you guys want to do the second? We can do the 5% really quick and then we can pause and we can all make our alcohol solutions. So we are going to do the exact same thing.
The teacher door, where we come in the morning.
Except we are going to be using 70% alcohol to make 5%. So we're diluting the 70 down to 5. So if you have your C1 V1 equals C2 V2 equation, you guys want to fill in the variables? So C1 is going to be 70, solving for V1, and our C2 is now going to be 5%, and we still want to make 500 milliliters. So V1 should equal, or my calculator went. Did anyone calculate that yet?
35.7 mLs, or I guess
Sounds right.
36.
5 times 500 equal divided by 70. Yeah, 35.7 milliliters. So that should be what you guys should have calculated. You guys okay with that?
Yes.
And then we're gonna add water again up to 500 milliliters. So you don't want to take 500 milliliters and then add 35 because that's gonna dilute the alcohol even more. Okay. All right, so you guys want to pause and we can make our alcohol. And did everybody make their Kool-Aid? Did you guys make Kool-Aid yet or no?
Yes.
I have not yet.
I have not.
Okay, so the third step in that preparation is adding approximately 0.3 grams of Kool-Aid, and in your pack you should have purple or green. So
Okay.
3 grams roughly to 100 milliliters of water.
Got it. I'll go ahead and make that now, right? That's what we're doing?
Yes, yes, if we can make all of our solutions now, that would be great.
Yeah.
Purple or green, y'all?
I did green.
All right, I'll do green too.
It's very pretty.
I like the green.
So we don't use both. Got it.
The other color you can use is orange. So any of the secondary colors, because the different percent of alcohol is going to draw out each color. Is anyone doing purple? Okay.
I lost my scissors.
I'm doing purple.
I don't know if y'all could tell, but I'm having a blast. Gotta have fun with the little things.
Okay. So Julie, what class do you use your chromatography in? This lab.
I've used it in the past in biology, just right before we do geoelectrophoresis to help explain what's happening with geoelectrophoresis. And when I have taught AP environmental, there's a soil chromatography lab that we do, and using that to determine nutrients and all that of soil.
So Laura, have you done this before with chemistry?
I don't do Kool-Aid. We do a different type. So I'm interested to see how this is going because um, we're in inter and intramolecular forces right now.
Okay, cool,
So if this goes well, then we are going to do it Friday.
awesome. Has anyone else done this kind of chromatography? Or any similar?
Not with Kool-Aid.
We
I've
did.
done this with protein before in college. This is
Okay.
way back. I've never done it with my class. Back when I was in college, I did it, but I only teach one biology class though, and they're freshmen, so I don't do stuff like this too often.
It's nice. They like
Yeah.
it.
Before we did a really simple chromatography in biology lab. We did the extraction of pigments for chlorophyll and other, pigments, and it was nice. It was really, really simple.
Yeah, with the paper and then the little bit of alcohol or chromatography solution, and then you can see chlorophyll phase. Yeah, in my class, we talk about like the properties of water and stuff first, and then get into the cell membrane after that. So doing this lab at the beginning of the semester really helps them with the vocabulary and like how the cell membrane works.
Tricia, after making the Kool-Aid solution, what do we do next?
So you should have the Kool-Aid solution made. You should have the 5% alcohol solution made and the 25% alcohol solution made.
I did not put this in a big enough beaker. Let me go get a bigger beaker.
Yeah, the beakers they gave us are only 250 milliliter, not 500.
Okay.
Do we just half it?
Yes, please.
Yeah.
$178. 6. Oops. 89.3.
89 and 161.
Yep, that's what I was just gonna put up here for you guys. So 89 and 161 would be for the 25%, and then 35.72. So 17, well, 17.9 or 18 plus water. So if you did 18 and 232, that'll give you your 5%. 18 alcohol and 232 water. And just let me know when you guys are ready. And if you've done this, or if you would like to kind of pre-read through the procedure, the cool thing about these C18 cartridges is if you do everything the right way and then rinse it out at the end, you can use them forever. So you should only have to buy them once or get them once.
I think I fudged it a little, but for the most part, we got it.
Okay. Does anybody else? Are we making our like last one right now?
I have my 5, my 25, and my Kool-Aid mixed.
Perfect.
Do we keep going or we stop?
If you're really comfortable and you want to keep going, go for it. I would just make sure, because you have to treat those cartridges, so you do have to put the alcohol and then kind of like plunge it out, and then you do have to put the water and plunge it out. And then just keep in mind that these cartridges, like I always tell my kids, it's like a one-way system. So you're not going to suck the Kool-Aid up through it. So I always have them take it off and take this out. And then put this cartridge back on. And then put the solution in. That way you're only pushing stuff through.
Will you say that one more time?
Yeah, so
Yeah, show it one more time.
these, let me see, these cartridges, I always tell my kids it's a one-way system. It's just through it, right? So you don't want to suck things back up. You don't want to suck 25% alcohol back up the chromatography column. So if you have them take this off and then pull out the plunger and then put this back on, then it's safe for them to pour and it won't spill out. So once you
The
do
plunger
that,
comes out?
yeah, pop it right.
Oh, okay. I was afraid I was gonna break it. Was giving me some resistance. I don't want to break it. I have a bad habit of breaking things. Okay. All right, cool.
And then you can put 10 milliliters of your concentrated 70% alcohol into the whole syringe.
Oh, okay. Just so y'all know, this is only my second year teaching, so I'm learning many things today.
That's awesome.
So I'm sorry if I seem like my head is in the clouds, because it probably is.
Mine too.
Okay.
At the end of the day, after a long, get a little tired. And then once you have the plunger out and you have the column back on, then you want to put 10 milliliters of 70% alcohol in the syringe.
Of the 25%?
70%. Because we're on step 1, so we're like pre-treating this chromatography column.
Oh, okay. Got it. I done put it away. All right. It's maybe a dumb question. It's not going to leak out, is it?
No.
Not with the cartridge on, but if you don't have the cartridge on, it will.
Okay. I got the cartridge in.
Tricia, it doesn't look like you have like this white piece inside of here. Like, does that come
Yeah.
out?
I do. Look,
Can you see
Oh,
it?
you do? Oh,
yeah,
okay.
that's the filter,
Oh, so keep it on there.
Yes.
Okay. And Trisha, can you explain to me again how to make this alcohol solution? My dogs were like attacking each other,
Oh.
so I had to leave. All right, so because I remember we said we don't have like a 500 milliliter beaker. So
Yeah,
what did
so
we do instead?
so why don't you make the 5% first?
Okay.
And if we half everything for the 5%, you're gonna take about 18 milliliters of the 70%
no.
alcohol.
Okay, so 18 milliliters of this.
Yes. And then you're gonna add 232 milliliters of water.
Water.
And that
Got it.
halves everything to get you 250.
Okay. Thank you.
You're welcome. And everybody else, are we at this?
Yes.
Okay. So once you have your 70% alcohol in your syringe with the chromatography column on, then you can put the plunger back in. And then if you have like a waste beaker or a sink, then what you'll do is you will plunge that 70% alcohol through the chromatography column.
Yeah, don't put in the plunger unless you want to miss. Put it over a beaker first.
Okay.
Yep.
And you should see your chromatography column still is white. Nothing has changed. We're just treating it. Because the 70% alcohol is going to be non-polar, pretty non-polar and pretty hydrophobic. And I have a picture of these molecules that I can show you in a minute. So we put the alcohol through. Step 2 says repeat step 1 using 10 milliliters of distilled water. So again, you're going to want to stop. You're going to want to take off the column. And then you're going to want to pull the plunger out. And then put the column back on. And then at
Is the column supposed to resist me a little bit? Like it's only coming out in drips for me. Like I'm pushing on it and it's you're muted. I can't hear you.
Yes, it'll go slow.
okay, thanks.
Okay, I didn't know.
You're
Thank you.
good.
Make sure I didn't want to break it already.
And then again, you can do the same thing. You can plunge the water through the column, just into like a waste beaker or into the sink.
Is tap water okay?
Tap water is, I've used tap water a lot because we don't always have distilled water. Distilled would be ideal, but my stuff has worked fine with tap.
Thank you.
You're welcome. And once you've run the alcohol through and then you've run the water through, now we're going to run 10 milliliters of grape Kool-Aid through. And the directions say that you can suck the Kool-Aid up. But I just always stress to my kids because they'll start pushing stuff all which ways. And I just always try to be consistent to have it just go through. So I would always tell my kids, pull the column off, take the plunger out, and then put the Kool-Aid in and then push it through. Because you should be able to use these forever. But I definitely have had some kids do I don't even know what. And then I can't use them anymore.
While everyone's doing that, can I tell a quick story?
Yes, please.
You know, you guys seem cool. So one time when I was student teaching, somehow during a lab, kids set the trash can on fire. It was like one of those big rolly trash cans. And I was just a student teacher. I was just trying to be helpful. And the best thing I could think to do was we have an outside door, or in that classroom, we had an outside door. And so I took that trash, and it was like in the middle of the trash can. It was like, it wasn't big fire, but it was a fire. I rolled that sucker outside so fast. It was so funny. But I don't know. I think they were doing, I don't know if y'all have ever done I think it was specific heat. They were like burning kernels, like different types of nuts and stuff. And I think someone had thrown a nut away and it was still kind of hot and it ended up setting the paper in the trash on fire.
Oh my gosh.
So ever since then, whenever we work with like burning substances, I always clear out the trash can of like any like burnable substances. And I tell them, I said, please wet it with water, whatever you're throwing away. If it was set on fire or like heated, wet it with water before you put it in the trash can.
Wow. That's a good story.
It's funny.
How much Kool-Aid do we put in each well?
So if you look at number 3, it says place this well plate. And then put 10 milliliters of Kool-Aid in it and then suck it up. But like I was saying, to keep it consistent for my kids, I just have them put 10 milliliters of the Kool-Aid directly into the syringe. And then what you can do is then push that 10 milliliters of Kool-Aid into the first.
So all 10 milliliters goes into one well?
So the well plates,
It doesn't look like it's gonna fit.
no, so you'll have to go from like, once you have the 10 milliliters in here,
Yeah.
you'll have to kind of like switch to the next well plate as it fills. So once the first well plate is full, then you'll go the second well plate until
we're-
all your
we're
10
filling it
milliliters is
totally?
gone. I'm sorry?
So we're completely filling it?
You're putting 10 milliliters of Kool-Aid into the syringe. And
I
then
got that, but I'm talking
Okay.
about the well.
Oh, got it. Sorry. Yeah, so you can fill the well and then move to the next well.
Okay.
Sorry.
And so it's progressively getting more green? Does that make sense?
Can I see your,
Yeah, let me see the lighting in here. Like the first one was totally clear, the second one has a tint to it. Let me see. Can you see that?
yes. So, and that's all your 10 milliliters of green Kool-Aid?
Yeah,
Clear, and then you have some yellow?
yeah.
Okay. Nope, that's fine.
Why does it do that? And then
So,
my syringe looks like this.
yeah, so this, if you guys look at the syringe after you put the Kool-Aid through, you can see, so you have the blue, you have the green Kool-Aid, right?
Yep.
So just like the purple, it's made of two primary colors. So you're gonna have the blue and the yellow show up. And so if there's still a little bit of alcohol on your chromatography column, some of that yellow might come out when you push it through.
Huh.
And then if you guys look, so for example, this is kind of what that chromatography column looks like. It's like carbon 18, like 18 carbons, all with hydrogens. So when you're talking about like lipids or macromolecules, or anytime you're talking about those hydrocarbons, so this C18 chromatography column is super hydrophobic, super nonpolar. And then this diagram is for the purple Kool-Aid with the blue and the red. The yellow is kind of similar to the red, but you can see the blue molecule is going to be have a whole lot more of those hydrocarbons, and it's going to be more nonpolar than the red molecule. I don't know if you guys can see that. And then the red, or in our case with the green Kool-Aid, the yellow, you're gonna put 5% alcohol, so that color should come out first. And you can see in Laura's chromatography column, the yellow is at the bottom and the blue is at the top. And if you have purple Kool-Aid, what color do you see at the bottom of your column?
Red,
Red, and then the top color
purple.
should be, well, should end up being hopefully blue that comes out.
Oh, I'm gonna say
Yeah, I had
blue.
blue.
It just looks purple.
All right, yours looks purple. Blade.
Here's what mine looks like. I don't know if I did that right. It doesn't look the same as y'all's.
It doesn't. Well, so let's go ahead.
It
We
ended up doing this. Here, I'll show you.
Okay. All right. Well, so if your chromatography column, if you can kind of see those two colors, whether it's the yellow and the blue or the red and the blue, what you guys should do now is you're not going to put 70%, you're not going to put water, you're not going to put more Kool-Aid. Yeah, Shamika, that looks great. You're going to put your 5% alcohol. So that 5% alcohol that you made, you're going to go ahead and take your syringe off or your column off, take the syringe out, put the column back on, and put 10 milliliters of your 5% alcohol solution that you made into the syringe. And then on your well plate, you're going to go to the next well plate that's empty. And then you're just going to do the same thing. You're going to push out that 5% alcohol into one well, and then the next well, and then the next well.
I hope
Now
I'm
my
not messing this
cartridge is
up.
super blue.
Yay, that's pretty. Looks awesome.
Well, I messed up something, I think. Oh no.
Yeah, okay, so if you have the purple Kool-Aid, what color you should see coming out is the red. And then if you have the green Kool-Aid, what color should come out is the yellow. And then if like Laura, you said yours was blue. And if you guys look on the computer at Laura, see her yellow is gone. So what Laura can do now is move. So you want to run it until it's like not really yellow anymore or not really red anymore. And then what you'll do is you'll do the same thing, but with the 25% alcohol. So we'll take out the chromatography column, plunger, put it back on, put 25% alcohol in. And
So
then,
now I got blue coming out.
okay.
More blue color.
And then you're going to do the same thing with the 25% is just go well plate by well plate.
Okay.
Okay, and what exactly is this doing? Like, explain the science behind this.
So what you guys are doing is that these molecules, like the blue and the red or the blue and the yellow, they themselves are nonpolar or hydrophobic. And you're running the alcohol solutions through the column because you want the different polarity of molecule to come out with a different polarity of alcohol solution. So when you run the 5% alcohol solution through first, it's 5% alcohol, 95% water. So that solution is, depending on how you want to say it, it's the 5% is less hydrophobic or more hydrophilic or more polar or less non-polar than the 25% alcohol is going to be. Does that make sense?
Yeah, why the color? Like, why does the 5% do one color and the 25% do the other?
Because of the chemical arrangement of the molecules themselves.
Oh,
Because they are also hydrophobic. And so,
cool.
like for the purple, the red is less hydrophobic than the blue. The blue would have more of those hydrocarbons that would make it more nonpolar or hydrophobic than the red or the yellow.
Does the rule that says polar attracts another polar molecule applies to this? Is that what the science
Yeah,
behind?
so
Okay.
that's what I was gonna say next. It's like that like dissolves like.
Okay.
So
Thank you.
you're treating that chromatography column, and then those molecules, the red and the blue or the blue and the yellow are sticking to it. And then as you put the 5% through, it's drawing that less hydrophobic molecule, the red or the yellow, out first with it.
Well,
Well, mine,
this is
mine
pretty
looks
cool.
kind of crazy. I don't know if I did it right. That's my Kool-Aid. That's my 5% and my 25%. I started on this side.
Yeah, and
We
so
have the result. Yeah.
so I've had kids in the past that if their initial Kool-Aid concentration was too much, like it was a lot more than 0.3 grams, sometimes the colors get a little bit messed up. But you can, in yours, you can still see the yellow came out before the blue, Haley.
Yeah.
And then the red should come out before the blue. Do you have yours, Blade? I don't know. Is it Blade?
Yeah, where's the purple peoples at?
I'm trying hard not to spill it on my computer a second time.
A second.
Okay.
Yeah,
Oh, it looks
I got
good.
the
Yeah, I
blue.
see.
I got the
red and
blue.
okay.
The blue.
25% conversions were 25%
I have them right
was
here.
you started out with 178.6 milliliters, and then you added 321.4 milliliters of water.
And then we halved that.
Yeah,
I'm
if
sorry,
25
I wasn't listening. I was trying to show you my well. Can you
Oh,
see?
sorry.
no,
So-
you're good. Would it help if I showed you? Oh, wait, that's backwards. Hang on.
No, it's fine.
You
Oh,
can
it
just,
was? Okay.
you can just say it again for me, please. I was
No,
just
I
trying
got
to
you.
show you my well.
So you started out with 178.6 milliliters of your alcohol,
Uh-huh.
and then you added 321.4 milliliters of your water. And that should give you 500 milliliters total. And I think she said if you didn't have a big enough beaker, you could half that.
Okay.
I had extra beakers, so I used 500.
Okay.
Okay.
And if you half it, your numbers came down to like 89 and
161.
161. Thank you.
And
Thank you.
the 25% pulled out the blue and the 5% pulled out the yellow. Is that right?
Yes.
Wow. That was pretty cool.
And if you do the orange, which is yellow and red, the yellow comes out before the red.
Wait, so the yellow was supposed to come out for the 25%?
No,
Or 5%?
5%.
if
Oh,
you use,
I had yellow the first time without any alcohol.
Yeah.
So
That's
If-
just for the green, right?
Yes.
For the grape, what did yours look like?
red should come out before blue. And if you guys wanted to add orange to the mix, like especially if you're in chemistry or something, if you're going to look at all three color molecules, if you do the orange, I believe it's the yellow that comes out before the red. So you can actually, see that yellow is the most polar or least non-polar, and then it would go red and then it would go blue.
is it eventually supposed to go clear?
So yeah, that's where we get, so once you've run the 5% through, and once you've run the 25% through, you might need, if you still had blue in your cartridge, you might need to run more 25% through. So
Okay.
it should be clear at the end.
I run a little bit more just to clean it out anyway.
Can
And
you,
how much do these little tips cost? The
That's-
chromatography.
that's a Megan question. She has the ends with the company that makes them. I
Just
don't know.
wondering how much we would be looking at to run a lab.
Well, one of the things that, and Megan might be in the other room right now. One of the things that Megan will do for you is one of the things that you're supposed to do at the end of this is like pick a lab or something that you want to implement, and she'll send you everything you need for it. So she would send you a class set of all of this to use.
Nice.
But then the cartridges, I'm not sure what the cartridge is. I know with obviously with the expensive stuff, like we'll do some mini PCR. Obviously you have to send that back to her. But I don't know with the cartridges because they know the company that makes them. I don't know if he just donates a bunch. So I don't know if you'd have to send these back or you would just have them forever.
Yeah. And about how long would they last with the average high school knucklehead?
That's a great question. I might lose one a year.
Oh, that's not bad.
It's not bad. But so in order to, if you guys look in your binder at the next page, it does tell you that the columns are 100% reusable. That is, unless the kids do something, right?
Right.
But
They will find a way, I'm sure.
I know. So once your column is clear from running the 5 and the 25% through, it should be clear, but then you want to run that 70% back through it.
Right, right, to clear it out.
To
So
clear-
you should run it until it's clear, because can you see how there's a little bit of blue in mine?
Yeah, and that usually doesn't end up mattering.
Yeah,
If you want to try to run some 91% through, that would be great. If you have any 91, some of them have been so messed up. We've tried to take all kinds of alcohol and push it through, and that's when we just throw them away. I don't know how to fix that.
Time probably has a thing to do with it. The longer you leave it sitting, the harder it is to clean it out, I guess.
Yeah, but once you run that strong 70 or 91% through, you should be able to just put it away for the next time.
and it'll sit over the summer with no problem.
Yeah, everything is fine. I
Nice.
just have all my chromatography stuff in a little tub and pull it out the next year.
Wow.
Any sensitivity to heat or anything that we need to worry about?
I just leave it in my classroom, so I don't think
Well,
so.
our school turns the heat off.
Ours does too.
Or the cooling off.
Yeah, ours does too.
Trisha, do you mind sharing that sheet that you were showing the polarity or
Does
you know?
she?
Yeah, yeah.
So are you guys okay with that? Because sometimes chemistry is not always my strong suit. I can talk about stuff in terms of the cell membrane, but I'm a little rusty on those intermolecular forces. So
I'm just looking at this spot right here, that if you could share with that to us. I think we can use this in AP Bio when we
for
talk
sure.
about, when we're talking about polarity and also like functional groups, because for sure there's functional groups that are involved here. This yeah, this
For
sheet
sure.
would be useful. Thank you.
For sure. So what I can do, and I don't know, oh, Megan, okay. So what I
Hey.
can do is I can take a picture of it through, and send it to you on like PDF. And then you can share it or put it in the Google file.
Yeah, thank you
Yeah.
so much. Really
Okay.
appreciate that.
Yeah, no problem. Do you guys have any other questions about the lab? One of the things that's pretty cool is like, I know you guys had talked about using the pigments from plants with the paper. But one year, and maybe you can help me, Megan, we also had a guy dissolve some leaves in alcohol and run that through the chromatography column. So you can
Yeah.
use it. It's a little bit more versatile. You can turn it into inquiry and give the kids maybe some different alcohol percent options, and then they could see what comes out better. And like I said, you can add the orange Kool-Aid.
I wonder if you could do this with different I got a teacher here. She loves marine biology. I'd probably share this to her. I wonder if you could do it with different like bodies of water. So like you could do like pond water, river water, ocean water. I'm just curious. I don't know if you could do that with those things.
I don't know. I think it would have, I mean,
Of course, you'd have to have color in it.
yeah, I don't know if you could look at something that was like more eutrophied,
I don't know, I'm just
maybe, but
brainstorming.
I don't know, like the more substance you have, like algae, that if it would clog it. Probably.
You could use it in the, I was a marine science major. You could use the chromatography for ion chromatography, but I don't think you could do it with
The
these little
carbonate.
tips. Yeah, uh, I
I
don't
think
know.
I did
I mean, you could
ion. I think
do,
that's what I did was ion chromatography because I majored, my major was in chemistry and physics. So that was like my big thing. Not so much biology, but I think that's what I did. That's why I was thinking.
I mean, you could do liquid chromatography with the algal blooms and stuff like that you have in the different waters, but just a general collection of pond water, salt water, river water, whatever, it'd be a little bit more difficult in this type of lab. You would need more specified equipment.
Gotcha. I was just curious.
Curiosity is our middle name. That's why we're science teachers.
Yeah. Yeah.
I look forward to hearing more about your marine biology stuff.
Yeah, it's super cool.
Yeah. Do you
And then
guys?
hey,
Oh,
I'm
sorry,
back, by the way, Trisha.
sorry.
Was there a question for me, like, that I still need to answer?
Yeah. About how much are these little tips?
So if you buy them from Sorbtech, the guy's email is on the care sheet that's in your binder.
Yeah.
You can get a box of 50 of them for like 200 something. So that's enough to share in your entire department.
Yeah.
So they work out to like $3 a piece. But if you buy them from Flynn, they're like $11.
Yeah. They are expensive.
Yeah.
Flynn is just
So if you choose to do this as your lab, I'll send you a class set. So like enough for your groups. And so that way you can just keep those and use them repeatedly.
Nice.
Just
This was a
make a
great
nice
lab.
little kit box and keep it forever.
yeah, this was fun. I like this.
Yeah.
So there was
Kids
mention of
love it.
doing it with there was mention of doing it with leaves. Do you guys have any resources that you could send me on that?
Yeah, so I'll put it in the Google Drive. One of the teachers from Jasper County made a leaf protocol. So yeah.
Yes, please send that. Can you send that to everybody?
Yeah. So I'll just put everything in the Google Drive and let you guys know when it's there. So probably like Thursday.
And then
No
I'll send
rush.
you a picture of this tomorrow, Megan. Okay.
Awesome.
Does anybody else need anything for the day?
We're good. Thank you so much. This is really, really, really
Yeah,
interesting.
this was fun.
This
Yeah,
one.
it's cool.
Yeah.
It's a really good lab. It's neat to have them do lots of different chromatography throughout the year. Like we still do the paper. The kids love this. So
As a teacher, you get a lot of professional development, but as a science teacher, you don't get much in this form. And so this brings your joy of science back. This brings your curiosity back. Like I want to do this with the kids. I want to share it with them. Where I usually sit in the library and listen to how I'm supposed to teach whatever and it doesn't apply. And
Why don't you bring literacy into a science classroom?
right. So this was so much fun.
I'm glad you enjoyed it.
I'm so glad to hear that. That means we're doing the right thing.
Yes, yes. And I'm trying to share it with as many people as I can because you don't really get this stuff. Like this is what we need. We need labs that we can do. We need somebody to explain that what we might not necessarily know all of, in just a safe place that you can do it.
Yeah, some people didn't go to college automatically and did all that sciencey stuff because some people don't have that science major. So
Mhm.
I can see how this can be beneficial to science teachers.
Nikita's raising her hand. Yeah, so I know. Well, and then even like people who got a science teaching degree maybe took like one biology class. And so you maybe didn't spend a lot of time doing labs. So yeah, we're happy to bring you guys all the hands-on stuff and we'll have more in the newsletter. We do a lot of stuff with mini PCR. So we'll do at least like one hands-on workshop with them. Like at the equipment depot, and a lot of times they'll do virtual too, like send you the supplies like we did. So yeah, just keep an eye on the newsletter for upcoming stuff, and we're here to support. If there is something you want to see, let me know
Awesome.
and we'll help.
You guys need
But if there's
anything?
nothing else,
No, we're good. Thank you.
Okay. You guys have a good night.
Thank you so much.
Megan, I had a quick question for you,
yeah,
if you don't mind.
Bye.
yeah, I'll stop recording.